Hello friends, today we are going to learn how to repair a dead laptop motherboard. So we'll open a schematic diagram and the concept of the motherboard, how the signal flows. I'll show you all these things on the animation basis. So let's start. Now we learn this sections. We categorize this entire section in three parts. This is section A. We call this is actually battery adapter in and battery charging sections. Okay, so we called it A sections, and this section is a generate a 3 volt and 5 volt. It's a 3 volt and 5 volt always voltage section. We called it a B sections, and here are three components: SIO, super input output controller, then the PCH and the bias. So there are three components. We called it C sections. This sections is basically responsible to turn on the laptop. So there are three sections. So what this section do? This sections take two inputs. One inputs from here, this adapter inputs, and another input is there, the battery inputs. So either he takes either from here or from here, and he send this voltage to this section. This section is generate a 3 volt, and this 3 volt given to this SIO as well as to the PCH and bias. Then after the power button, they coordinate all the signals. There is a certain protocols are there. They send one signal, received another signal, and after that the laptop is turned on. So let's start. First, as soon as we connect the adapter, suppose there is 18 volt, it's connected here. This 18 volt pass directly from here, pass this resistor. We can check this voltage here. This is the current sensing resistor, and this resistor's value is 0.2 ohm. It's a value, it's a 0.2 ohm. It's a very negligible value. So here you should get a 18 volt, and if you are not getting 18 volt, that means something problem is either from this MOSFET or this chips. Okay, after that this chip generate one signal that is called AC in signal or the AC OK signal, and this signal sent to the SIO saying that adapter voltage is connected. It's called the AC OK signal. It's a 3 volt signal generated by this battery charging chips. Then this 18 volt pass to this sections. You can see in this animation this 18 volt pass here. This section is basically generate a 4 voltages, 2 linear voltages and 2 pulse width modulator output. The linear voltage is sent out immediately after he receive this input voltage. This 18 voltage goes to his V in pin. It's V in pin, and as soon as he receive this 18 volt, he generate a 3 volt, and this 3 volt going to SIO at its VCC pin, and if it is a bias is there, bias pin number 8. So you have to check 3 volt on the SIO, 3 volt at SIO at his VCC pin, and if you can't get this voltage, then you have to go this section and to check VRG3 output, and if the VRG3 is not coming but V voltage is coming, then in that case this chip may be the faulty. You have to replace this chips. So friends, after getting voltage to the SIO as well as to the bias, now this SIOs require a reset signal. It's called the EC reset. This is something a delay signal. Here is one RC circuit, resistor and capacitor is there. This is RC circuit generate a EC reset. It generate a 3 volt and reset the SIO. This is step number 5, and then he checked this thermal trips and lead sensor. Lead sensor is basically a magnetic sensor. There is one magnetic sensor and thermal trip. That means your CPU should not be hot. So in this way, if all these criteria are perfect, then SIO start communicating with the bias. Bias pin number 1 is a chip select, pin number 2 is a read pin, So SIO start communicating with the bias, and now is ready to turn on. Now this is a power switch. The power button is sometimes called NBS WR on or PBT or PWR BTN, like that. So you have to locate this pin on the schematic diagram. So here is mentioned PBS NBS WON. So here at power button you will get a 3 volt, and suppose this one is a switch. The switch one point is connected to the SIO, the another point connected to the ground pin. So this is a switch. So now when we press the power button like this, so here one pulse will generate, that is a 303. The pulse will generate, a 303 pulse will generate. So as soon as SIO received this pulse, 303 pulse, then SIO send one signal that is called EC on signal. He generate a EC on signal. Suppose this EC on signal will not generate by the SIO, then in that case your either SIO could be the faulty or your bias may be the corrupt. If the all criteria are perfect, but after pressing a power button SIO is not generating the EC on signal, that means either your SIO could be the faulty or bias may be corrupt. So first what you have to do is you have to flash the bias, and if the problem still not solved, then you have to replace SIO. So like that. So SIO will generate this EC on signal. After EC on signal, this EC on signal going to this 3-5 section, this always voltage section, and this 2 buck converter will start, and they generate a 3 volt and the 5 volt at its output pen on the capacitor. So 3 and 5 volt will be generate. After that, after the 9 step, here are some sequence are there. All the signals goes sequence one by one. So 1, 2, 3, 4. So it's very easy to find out what is the problem. So after 8, then 9, and then the 10 step. The 10 step, what he is doing is SIO generate a PCH enabled signal. And after the PCH enabled signal, it trigger this MOSFET. What he do is it trigger this MOSFET. So this MOSFET drain and source short each other, and this 3 volt pass to the PCH got the power. This VCC DSW3_3. So this is name of that signal, VCC DSW3_3. Here you should get a 3 volt. If you get a 3 volt here, that means PCH got a power. After that, step number 11, PCH get another confirmation signal, that is called a DPWROK. Here also you should get a 3 volt, and then now the PCH ready to work. After 11, VCC DSW DPWROK 3 volt. The another 3 volt signal is required, that is RTC reset. That should also a 3 volt. Now if everything is perfect, then SIO generate a RSM RST signal. Step number 14, 3 volt. After 10 milliseconds of delay, SIO generate another signal, that is called PM power button. It's called a digital power button. This signal inform PCH that a power button is pressed. Now what to do? He send this signal to PCH informing that the power button is pressed. After receiving this signal by PCH, then PCH generate 2 signal, that is a wake up signal. Actually the power supply, all the buck converter are on slip mode, that's all on off mode. Now we have to wake up that signal. So PCH has to send 2 wake up signal, that is called slip mode 3 and slip mode 4. It's called SLP S4 and SLP S3. SLP S4 and SLP S3. At step number 16, if everything is fine from his end, then PCH generate these two signal, SLP S4 and then SLP S3. These both are 3 volt signal. So as soon as received this two signal by SIO, then SIO individually turn on different buck converters. So there are different buck converters are there for RAM supply, for system supply, for core supply. So SIO turn on a different buck converter one by one. So friend, in this way the laptop turn on. So thank you very much.